and welcome to our explanation of how the body creates hormones during puberty. First of all, the hypothalamus will release a little protein called GnRH, and that will go to the pituitary gland, where it will then release the luteinizing hormone, which then, in the process of testosterone, will bind to luteinizing hormone receptors in the Leydig cells in the testes, which then creates the production of testosterone. Similarly, when the pituitary gland releases LH, it will bind to LH receptors and the granulosa cells in the ovaries, which then creates the hormone we all know as estradiol. Thanks for watching. This is how vitamin D is synthesized via PTH signals to the kidneys. So first of all, cholesterol is converted into cholecalciferol in the skin. Then, cholecalciferol is then converted into calcidoil in the liver, which then, with the help of PTH in the kidneys, calcidoil is then converted into vitamin D in the kidneys. Hello and welcome to our video on how vitamin D helps create calcium in response to hypocalcemia. So first of all, after calcidiol becomes vitamin D in the kidneys, vitamin D then binds to a vitamin D binding protein in the bloodstream because it needs a chaperone because it is not water soluble. Then this combination moves over to the nucleus of this in cells of small intestine, in the small intestine cells, where it then binds to a vitamin D receptor and forms a hormone receptor complex. This combination then binds to DNA in the small intestines, which causes an upregulation of the protein called calbindin, which allows a channel for calcium to be digested in the small intestines. And that is how, with more vitamin D, comes more calcium. Okay, so this is the mechanism of both steroid and non-steroid hormones. Okay, so first of all, with the steroid hormone, because it's not water soluble, it needs to bind to a transport protein in the blood to get to the cell. Once it reaches the cell, it does not yet need a receptor, so it does away with the transport protein, enters the cell, then binds with another hormone cell receptor to form a hormone receptor complex, and then upregulate or downregulate different proteins with DNA inside the cell. Separately, with a non-steroid hormone like T3 or T4, it does not need a transport protein much like the steroid hormone does, so because it's water soluble. So instead it travels through the blood and then needs a receptor to get into the cell. Once it's in the cell, it binds with another receptor and forms a hormone receptor complex, again upregulating or downregulating different proteins in DNA.